Good morning, ladies and gentlemen, and thank you, Janet, very much for your introduction, and thank you to the Co-Council for giving me the opportunity to speak here today. And please forgive my Schwarzenegger accent. It just doesn't want to go away, but that's what it is. So steel has in many ways a bit of a reputation of a commodity, but I can assure you when you want to play in the top quality level, there is no such thing as commodity, and you see a lot of that in the technologies that you're using. And steel at that level has a lot of sophistication, a lot of quality requirements, and a lot of opportunity. US Steel was a great company when I worked there, and I had many opportunities to work on some interesting projects. Turns out that the biggest project I worked on, when it was ready to go, they came to me and said, "John, good work, but you know what, if we do this, everything else we have is obsolete, so just forget it." Oh. And that was the end of a big project that US Steel worked on more than 20 years ago. It was written up on the Wall Street Journal on the front page as a super secret project, and then everybody walked away and said, "Cannot do it, sorry." What we did since then was working with some suppliers, including Babcock and Wilcox, and one of the gentlemen here will comment on that later. We improved the project tremendously. When we worked on this project at US Steel, there was no energy recycling part of it, which became a key element of our strategy. And perhaps more importantly, we saw what the steel industry was doing in other countries, most notably in Europe, working on next generation steels. They are called third generation advanced high strength steels. And now the Germans are working on what's called medium and high manganese steels, a totally different ballgame. I mean, it's fascinating what you can do if you focus on better technology and you find a practical way to use it and to implement it and to have customers that want to use it. In addition to that, sustainability and climate change were very important parts of our work over the last 10 years. After I came back from Thailand, we teamed up with some people in Ohio, and we worked with some of the auto industry and with one of the big utilities. And we learned a lot about how to optimize sustainability using the material that we understand and that we know, which happens to be steel. What you see here is a depiction of a steel project that we have been working on in southern Ohio on the Ohio River. On the left, you see some barges on the river. Then you see what we call iron-making cogeneration plants, and towards the right, you see the steel plant, including a finishing operation. This is a site that we already had under option when we had a Russian partner. And as life has it, we had all the permits, we had all the funding ready to go, and then Mr. Putin invades a little country in the Caucasus, and the Russians had to walk away. And so you can run into some really interesting experiences when you work on big projects like this. Next. Here's an interesting picture that shows you where we are in the American steel industry. It's a sad decline. I didn't originally come from the steel industry, so when I started working here, we had a very good industry at that time, but from the first oil crisis in the early 70s to very recent in 2013, imports took off from less than 18% to more than 60% of our steel consumption in this country, more than 60%. It is unbelievable. And I don't need to tell you all the political ramifications and the industry ramifications, but the impact on manufacturing, on jobs, on all kinds of industries is amazing. There was a short period of time in the 80s and 90s where a couple of mini mills established a sort of a trend reversal, but they were reined in and said, no, you cannot do all this. So the trend continued, and the imports kept getting bigger and bigger. Now, interestingly enough, many people are worried about China. China is not the biggest importer in this country. They are ranked number 7. So this is all high-quality steel that we cannot make in this country. That's what's being imported today. So what we felt out of this is focusing on non-commodity material, but focusing on really high-strength and highly advanced materials, starting with the auto industry, but going into a number of applications. There was a great case to be made, and that's when we worked with this Russian company that unfortunately ended up having to pull out. Next. So what coal and steel allows you to do is connect the dots in ways that most people hadn't thought about. And this is really cross-cutting, when we said it earlier, is the opportunity that you can see with coal and steel. Since nothing was invented or invested in this country in more than 50 years, the last high-class steel plant in this country was built in the 60s. Everything else were really recycling companies that cannot really compete on the top level. With that, we think we have an opportunity. We had a Russian partner, we got very far, and at the end, we couldn't get there. Using coal twice, wasting nothing. That's essentially the motto of our products. We are using essentially low quality iron ore and medium quality coal. We don't need coking coal. This is a technology that doesn't require it. And very importantly, we are restoring a number of critical supply chains in this country that don't exist anymore. Next. When you go through this and you see essentially a unique combination of existing technologies, there's nothing in there. It all exists. We are having an iron-making technology. We have waste heat recycling and cogeneration, and we go into premium quality steel. We are using iron ore, we are using coal, pet coke, and bio-coal. And we make steel for the world markets. This country doesn't need to be importing everything. We can, for a change, also export something. Next. So what we do is we make steel for the domestic market, and we will probably sell something overseas, or at least in North America. And excess iron we can sell into the local markets for other mini mills and for foundries, and the electricity we are selling into the grid. Next. I don't want to go through all the details here, but I can assure you that there is huge interest in projects like this in North America. We had a couple of meetings with representatives from the Department of Energy already. We have very strong interest from the auto industry. There is a huge need for better raw materials for a number of industries. And at the end, what we are doing could also become an export article for carbon management in other countries, because this is a very innovative idea, and yet we are not innovating anything. It's all existing technologies. Next. The basic idea is very simple. We are using a technology that was invented in Ohio in the 60s, patented in Ohio in the 60s. And of course, like so many other good ideas, they get ignored. And we picked up on it when I was at US Steel. We ran all the numbers. We realized that this is the low-cost way to use moderately quality iron ore and coal. And the material that comes out of here goes into what's called a submerged arc furnace, and that makes iron product. Not to be confused with steel, only iron. And then the hot reaction gases go into a large, essentially utility scale cogeneration boiler that uses waste heat and supplemental firing, so it gives us a large range of flexibility. And the power goes either into one of our own melting operation, or it goes into the steel making operation, or it goes into the grid. And pollution control, there is a lot of sophisticated pollution control systems out there. We chose some of them that are operating dry and don't create a lot of waste and a lot of sludge. And so what we have is essentially two revenue streams: electricity and iron products. Next. We have a gentleman from Babcock & Wilcox here with us today, and we have a very close relationship with B&W. And Joe, if you wouldn't mind saying a few words about our work here, and maybe you can find a microphone here.
Yes, can we get the microphone up here, please?
Thank you, John. B&W and NSI have had a pretty long relationship, about 10 years now that we've been working together. And B&W is really excited about this project for a couple of reasons. The first is, as you can see, this is core technology for us. It's nothing out of the norm. It's very robust, well-known technology. The one novel thing about it is we get about 40% of the heat input as waste heat from the from the iron process, which means we can fire about the coal we need to achieve 100% load is about 60% of what we would normally need. And that means we can meet all the emission requirements and all the permit limits without having to do anything novel. So it's a really cool and novel application of well-known technology, and we just applaud John and we appreciate his partnership through the years.
Thank you.
So I'll turn it back over to you.
All right.
Thanks, John.
Thank you, Joe, very much. And what this boiler is, and it's what's called the classic Benson boiler. We have the classic boiler structure here. We have waste heat coming in from the iron making process. And back here we have NOx controls through, again, a standard selective catalytic converter system. The first plant that we are working on in Ohio is a 500 megawatt boiler. We have worked with B&W already on 800 megawatt and even 1,000 megawatt boilers that still meet all the new emission standards without the need for carbon capture. And if we can go to the next slide, please. This gives you a quick overview as compared to one of the AEP plants in Ohio that are being shut down. The columns here represent the heat rate of electricity generation, and the red line represents the CO2 emissions on the right side per megawatt hour produced. This column here is the heat rate of about 10,000 BTU per kilowatt hour produced in a high quantity power plant in Ohio, and the CO2 emissions are up here, which is about 2,100 pounds per megawatt hour. The next column is the average of the American coal-fired fleet as of 2014, all published information from the Energy Information Administration. So you see the CO2 is a little higher. When you go to the average of the American natural gas-fired fleet, you see that the CO2 is much lower, but the heat rate is still about 8,000. And then you come to two columns on the right, which is our design for the Ohio project. And what that means is that our coal consumption is down here. So it's about half of what you see in a good coal-fired plant, as Joe just said. And if we go a little further and we add some bio-coal fuel, co-firing, then it gets even better. And the CO2 that you see here is in all coal about 1,000, and in coal plus bio-coal even less. You see three dotted lines here. One is the CO2 limits for natural gas-fired fleets of about 1,000 pounds per megawatt hour. Then EPA announced an 1,100 line that we actually designed for when we designed this plant, and then they lifted it up to 1,400. But you can see that our basic design is already well below the 1,100 and certainly below the 1,400. So all these things essentially show you that you can use carbon in a more innovative way. There is no R&D required at this point. We can basically move forward with this fairly quickly. Next. In the Ohio case, using the metrics that DOE and others have published, we just compared the benefits of our project to the carbon emissions or carbon dioxide emissions of all the coal-fired plants in Ohio. And in 2014, all the coal-fired plants emitted 87 million metric tons of CO2. When you look at our design and you recognize the benefits from making better steel for the auto industry, and you allow the auto industry to build lighter, stronger, and safer cars, you all of a sudden come, and these are all metrics that the DOE has published and the auto industry has published. We can eliminate 55 million metric tons of CO2 with one plant alone. So it's a pretty big bang for the buck, and we are looking forward to building one and hopefully more than one here in the United States. Next. Ohio is a good place to do this. Ohio is the largest electricity importer in the Midwest for a total of about 25 million megawatt hours in the last numbers we have. A plant like ours that is designed to use 2/3 of the electricity internally for iron and steel production and 1/3 to sell into the grid and to drive the financing would essentially provide about 1.4 million megawatt hours per year. So doing this in Ohio is certainly a very attractive proposition. On the next chart, please. We did the same information for a project in Michigan and also for some other locations. We used a reference plant that is operating in the Lansing area, which has a heat rate, and the plant is still operating, but it is scheduled to shut down in a few years. The heat rate is about 14,000 BTU. The CO2 emissions up here. Again, here is the average of the American coal-fired fleet, natural gas-fired fleet. And now for an 800 megawatt unit, you can see without using any biocoal that we are still well below the 1400 limit. And then with biocoal, we are actually back below the 1100 limit that was originally proposed. On the next slide, you see the overall flow sheet. Very simple. There's nothing new in here. This is the flow sheet that you just saw. We use the electricity in our iron making process, and we use electricity in steel making. And whatever we don't use internally can go into the grid. We are also using thermal energy for combined heat and power if the location allows and justifies it. And we also had some projects overseas that for political reasons didn't move very far, but we are still working on it. You can use the CO2 as greenhouse, as fertilizer in greenhouses. And when you look at some of the things that people have done in this country, the biggest tomato farm in California is using CO2 as a fertilizer today. It's a fantastic plant. These guys did a wonderful job. So you don't have to all put it into the ground. You can use it for something else as well, and it's been done many times before. On the right, this is our specialty really is this end here to make super high quality liquid steel that cannot be done in this country today, and then making premium product steel quality for the auto industry. I can just tell you that when I worked at US Steel, we were making also very high quality steel, but the objective was to make it very soft, which by the way allowed us to sell lots of it because you needed more to build a car. Now that you go into high strength steels that are 4, 5, sometimes 6 times stronger. And in addition to that, using some of these new characteristics, they have a safety performance that allows you to absorb 3 to 4 times more energy in a crash situation when you have an accident. All these things are on the market in Germany today, but you cannot get them here. So the auto industry, understandably, is very annoyed about this and says, what can we do? Well, now we're working with them together, and we are getting some support from the DOE so that we can move with these projects forward here in North America. Next. On the steel side itself, just using everything that I just showed you, this is the energy consumption and the CO2 emissions of the worldwide classic steel industry that makes high quality steel today. You can see the CO2 up here and the primary energy consumption here. Our plant in Ohio will be operating down here. This is our primary energy consumption, and this is our CO2 emissions. No new invention, just putting things together that already exist. And when you go all the way to the right, you see a scrap-based mini mill that uses 100% scrap. The CO2 goes up a little bit because our assumption is that it uses coal-based electricity, and in today's market there is still a lot of CO2 here. So again, it's all existing, and it's obviously very, very attractive. Next. Coming back to climate change, we all have an obligation to work on this. There can be many different opinions, and I've heard many of them, but I'm not a climate change expert, but I've certainly educated myself over the years, and I realized that something has to be done. And frankly, in our case, it's very economical. It's very financially attractive. This does not increase any cost. What we are doing actually lowers cost. But and we got this out of a report in January from the Rhodium Group, using the numbers that this country has already committed itself with all the policies that at least have been documented by this group. There is still a gap of some 220 to 350 million metric tons by the year 2025. And we think with our technology and with the user community that we already see, we can make a significant contribution to closing that gap. And if we work with people like Babcock and Wilcox on their next generation carbon capture technology, which I've personally find fascinating because they're using coal and iron, which really made me happy. So looping with using these ingredients can be extremely efficient. Next. When you look at some of the publications from US EPA, if you look at the cross-cutting technology like we are proposing, we are essentially affecting every market, or virtually everyone. Agriculture, industry, transportation, electricity production, and land use. When you see how you can make biomass in a more controlled environment, it doesn't have to be trees, it can be switchgrass, it can be anything that grows in the area where you build a plant like this. You're essentially impacting every one of those areas that EPA is tracking, and you can see our CO2 emissions went down quite a bit, but now they're tracking up again. So something needs to be done to comply with our commitments. And of course, it certainly is a good tool of distributed generation and also for fairly high capacity demand response capability. The last item that I wanted to bring to your attention is, if you can go to the next one, please, is manufacturing. Okay, we lost millions and millions of jobs and subcontracted to other people. We have run up a $10 trillion trade deficit over just 15 years, $10 trillion. The impact is just unbelievable. But seeing the positive, we can bring a lot of that back because nobody outside this country has anything like this. So we can take the lead again, and we can restore some supply chains and some manufacturing bases that is second to none in the world.